Hello, 8th grade. This is your final math review for the year. So first, just like the previous ones, we have our self-reflection, just basically trying to figure out what you feel comfortable with, what you don't feel comfortable with, what you need more work on, and so on. The second page, again, starts out with vocabulary. So what I've done is I've gone ahead and defined each of those for you. So here we have absolute value, a number's distance from 0 on a number line regardless of the direction. So if you're going 10 units left, you still have a distance of 10. If you're going 10 units right, you still have a distance of 10. So that is always going to be positive. Base of a power, the number or expression that is being multiplied by itself repeatedly in an exponential expression. So if you have 4 to the 6th power, you're going to do 4 times 4 times 4 6 times is equal to 4, and I don't know how to do exponents on a Mac, but that base is the number that's being multiplied. Evaluate, define the numerical value of a mathematical expression. So if you have 2 to the 3rd times 4 squared plus 72, whatever your expression is, it's finding the actual answer to that. Exponent, the number written above and to the right of a base number that indicates how many times the base is multiplied by itself. So again, if we had 4 to the 6th, that 6, that floating number, is the value, that's your exponent. Power of 10, an exponential expression where the number 10 is the base and is raised to an integer exponent. So 10 squared, 10 to the 3rd, 10 to the 6th. That's going to be your power of 10, and you're always going to have a 1 and several zeros. Standard form, used to write very large or very small numbers efficiently, such as 0.00044789 as 4.789 times 10 to the negative 4th. Scientific notation, a standard way to write extremely large or extremely small numbers using a format. A times 10 to some nth power, where a is a decimal greater than or equal to 1 and less than 10. Okay, so it's always going to be between 1 and 10, 9.9999999, whatever, less than 10. And n is your integer exponent. Express, to represent a mathematical phrase, relationship, or value using numbers, variables like x, y, symbol operations, plus, minus, multiply, divide, without using an equal sign. So equation always has an equal sign, expression does not. Those are the difference between the two. Mass, this is more of a scientific term, the measure or the amount of matter or stuff that is inside of an object. So when you're talking about mass, a lot of times you use scientific notation because mass can be very, very large or very, very small depending on the object that you're talking about. So scientific notation goes along with that very closely. Molecule, 2 or more atoms that are chemically bonded together, again, a scientific term. And simplify, to rewrite an algebraic expression, fraction, or numerical expression into a shorter, more compact, or less complicated form without changing its value. So we're just changing how it's looking. We're not actually changing the expression, equation, whatever we're working with. All right, so now that we have those defined, let's go ahead and answer these questions. So tell whether you would most likely use standard form or scientific notation to represent each quantity. So the first quantity that we're talking about is a diameter of a basketball in inches. We can just write that down, the actual raw value, so that one is going to be standard form. The distance from Earth to Mars, that is a very large distance, so writing that out would take a very long time, so that one would be in scientific notation. The world population, this one you can actually do either, depending on if you want to write out the number in billions, or if you just want to shorthand it. So this one you could either do standard or scientific notation. This one's not overly large, like distance. So you could take the time to write it all out. You could be, so to speak, lazy and write it in scientific notation. Either answer would be acceptable. All right, number 2, select a positive number greater than 10, 100,000 million, and a positive number less than 1, 2, 3, 4, 5, 6 tenths, hundreds, thousands, 10,000. Okay. Express both numbers in standard form and in scientific notation. Use scientific notation in standard form to label your numbers. Okay, so we're picking a number greater than. So really you can do anything from 10,000,001 to positive infinity. So let's just go ahead and do okay, so that's for a number that's larger. And then here you can add, sorry, didn't realize you can see. Here you can add zeros. In here you can, the best way is to start by adding zeros, and then you can add whatever values that you want. Okay, so let's do, let's see. Okay, so these are the numbers that I'm choosing, and again, you can choose anything from 10,000,001 to infinity, and then add zeros here, and then just add numbers after that. Okay, so here are my original numbers. So these are standard form. And then you'll write them in scientific notation. So if you remember, what you're doing is you're taking the number, whatever the number is, the first number that you come to, left, working left to right. So here, the first number that I come to is 2. I would put my decimal point immediately after that and then count 1, 2, 3, 4, 5, 6, 7. So I'm going to have 2.5432 times 10 to the 7th. And then same thing here. So I'm going to go left to right, find that first value. Because this is smaller, I'm going to go to the left now. So 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be 2.56 times 10 to the negative 8. Positive values, you're getting larger. Negative values, you're getting smaller. So here's my standard form. Here's my scientific notation. All right, question 3. Explain what you do when you simplify an expression. How is it the same or different from what you do when you evaluate expression? So they are very similar techniques, but we'll just simplify them a little bit. Okay, so I'll just read that again. So you simplify an expression by combining like terms or using properties of operations in order to have the fewest terms possible. You evaluate an expression by finding its value. For some expressions, simplifying and evaluating result in the same expression or value. So basically you're doing the same process, simplifying. You might not end up with a single term. You might have 4a plus 2b plus 6c instead of a single value like 24. All right, so we're going to label this expression with at least 3 math or academic vocabulary terms from the top. So if we're looking at this whole thing, this is scientific notation. This is a power of 10. The 4 is the exponent, and then the 10 is also a base. Right. All right, so the first page of the actual review. Which expressions are equivalent to 7 to the 4th times 9 to the 8th? Select all the correct answers. So you have to simplify each of these to figure out if they are the same, because right now most of these aren't in a position where you can compare them. So you have to simplify them. So here I have 7 times 9 to the 5th times the quantity 7 times 9 cubed. So this 3 needs to go into both. So this becomes 7 times 9 to the 5th times 7 to the 3rd times 9 cubed. Okay, so we're distributing that. Then when we're multiplying, all we have to do is add those together. So I have 7 to the 1st, 7 to the 3rd, 1 plus 3 is 4. Then I have 9 to the 5th, 9 to the 3rd, 5 plus 3 is 8. 7 to the 4th, 9 to the 8th, does that match? That does, so that one is correct. Here we're going to distribute that 4 into each side again, so 7 to the 4th. When you raise a power to a power, you multiply, so that's going to be 4 times 4 is 16. That does not match, so that one is not correct. I'm going to distribute this as well, so this becomes 7 to the 8th times 9 to the 8th divided by 7 squared. When you're dividing, you subtract, so this becomes 7 to the 6th times 9 to the 8th. That does not match, so that one is not correct. All right, here, because the parentheses is around everything, I need to distribute this 4 inside everything. So this becomes 7 to the 4th times 9, 6 times 4 is 24. 4 times 4 is 16. So I have 7 to the 4th, and then 24 minus 16 is 8. So I have 9 to the 8th. This matches, so that one is correct. Here, you could either do it just the way it is, even though they're flipped, or you can rewrite it. So I have 7 to the 5th times 9 to the 12th, and then I'm just going to flip these, 7, 9 to the 4th. Again, when I'm dividing, I'm subtracting my exponents. 5 minus 1 is 4. 12 minus 4 is 8. This matches, that one is correct as well. Okay. Which expression is equivalent to 3 to the negative 5th? If you remember, anytime I have a negative, it's going to swap. So 3 to the negative 5th, that's the same as 3 to the negative 5th over 1. My numerator and denominator flip, so I have 1 over 3 to the 5th. We're going to look for that. 3 to the 5th over 3 is 0. 5 minus 0 is 5, so that one's not correct. 3 to the 5th times 3 to the negative 1. When I'm multiplying, I add, so 5 minus 1 is 4. That one's not correct. 5 to the 0. When I'm raising a power to a power, I multiply. 5 times 0 is 0. So that's going to equal 1. That is not correct. So 1 over 3 to the 5th, that is the correct answer. All right, number 3, a geology class studies a sample of rock and a sample of dry sponge. The rock sample has a mass of 1 times 10 to the first kilogram. The dry sponge sample has a mass of 2 times 10 to the negative 3 kilograms. Which sample has a greater mass? How many times as great? Show your work. So just by looking at my exponents, I have a positive exponent here and a negative exponent here. So because I have a positive exponent, this one is going to be greater. Okay, so the rock has a greater mass. Okay. And then basically, so 1 times 10 to the first is going to be 10. And then this is going to be 2 times 10 to the negative 3. So I'm going to write 2. Let's do it over here. And then here's my decimal, and I'm going to move that over 1, 2, 3 units. So I have 0.002. So I'm going to divide that by 0.002. And that it'll be 5,000 times greater. All right, number 4, find the perimeter of the triangle using scientific notation. Write your answers in the blanks. Okay, so here we have 6.7 times 10 to the 5th, 6.7 times 10 to the 5th, and 1 times 10 to the 6th. If these were all 5s, we could just add them and there wouldn't be an issue. But because this one has a larger distance than the other two, we have to do it this way. All right, so we have 2 of these sides, 6.7 times 10 to the 5th. So if I distribute that, then I get 13.4, you don't need that, times 10 to the 5th plus 1 times 10 to the 6th. So then I have 13.4 times 10 to the 5th. What I can do is I can take one of these 10s and add it over here, so this now becomes 10 to the 5th. So now they are in a little bit more common terms. So the 10 to the 5th, those just go here. If I add the 13.4 and the 10, I get 23.4. Your scientific notation always has to be between 1 and less than 10. So I need to move this over. By moving that over, you're going to add a 10 to here. So this becomes 2.34 times 10 to the 6th. All right, last page. Evaluate the expression 2 to the 3rd times 7 to the negative 8th over 14 to the negative 5th. Show your work. So the first thing that you should do is you should get rid of your negatives. So I have 2 to the 3rd times 7 to the negative 8th over 14 to the negative 5th. So these two are going to swap places basically. So this becomes 2 to the 3rd times 14 to the 5th divided by 7 to the 8th. And then what you can do is you can separate this 14. So then this becomes 2 to the 3rd times 2 to the 5th times 7 to the 5th, all over 7 to the 8th. So then I can simplify these two pieces and then worry about those two pieces. So basically I rewrote the 14 so that, because I'm trying to work with the 7 on the bottom. So these I can simplify because they're like terms. So 2 to the 3rd times 2 to the 5th. When I'm multiplying, I add the exponents. So that becomes 2 to the 8th. I have 7 to the 5th over 7 to the 8th. When I'm dividing, I'm subtracting. So this becomes 2 to the 8th over 7. 5 minus 8 is 3. So that would actually be a -3, but I'm just going to keep it on the bottom. Please feel free to use calculators tomorrow. Okay, so 2, let me see. There we go. 2 to the 8th. Oh, biscuits. I'm just gonna give you the answer really quick. It becomes 256 over 343. That's your final answer. Mostly just by breaking it up and giving values the same bases so that you can work with it better. All right, number 6. Which of the following values are between 7 times 10 to the -6th and 6 times 10 to the -5th? So if you remember, we are going to be, so we have 7, and we're moving 1, 2, 3, 4, 5, 6. And then we have 6, and we're moving it 1, 2, 3, 4, 5. So I need something, so maybe adding a 0 here, but not going quite to 7. So 6 times 10 to the -6th. But answer key doesn't have that one marked, and I'm trying to figure out why. So probably the best thing to do would be to write 6 just write each of them out. In standard form. And see which of them fall between there. So C, D, and E would fall between those two values. Excuse me. The mass of 1 grain of sand is about 6.7 times 10 to the -7th kilograms. An hourglass contains an estimated 2.1 times 10 to the 4th grains of sand. What is the mass of the sand in the hourglass? Write your answer using scientific notation. So basically what you're doing is you are multiplying these. We didn't really work on this too much, so you can actually skip it, but I will answer it anyways. Okay, so we have 6.7 times 10 to the -7th, and we're multiplying that times 2.1 times 10 to the 4th. So the 6.7 and the 2 times 2.1 become 14.01. So I have a -7 and a 4. So when I add those together, I get a -3. And then because this can't be here, I need to move this over 1. So I get this gets added to 1. So I have 1.401 times 10 to the -2. All right, so that is your review. I'll double check your test to see if there's anything that you can't do, and I will adjust it accordingly. Make sure you bring these with. You can bring calculators. Good luck and see you tomorrow.